Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. May all the peace and blessings of the Almighty Allah subhanahu wa ta'ala be on all of us. Now, as you can see today, I want us to look at the questions tested in Kcse on cell physiology. I cannot do all the questions, but I have sampled 2 questions that can give us much information about how questions are tested in Kcse about the cell physiology, that is the osmosis part. Now, as you can see here, we have an experiment that is done before and after. Now, the 2 diagrams, this one is showing before the experiment and this one is showing after the experiment. And as you know, there must be some observations, then you account for your observations. Now, class, the diagram above show an experimental setup, and this is an experimental setup for the process of osmosis. Now, the experimental setup was used to investigate a certain process in plant tissue. Very good. Now, explain the result obtained after 30 minutes. Now, you are supposed to explain. Now, before you explain, are you making any observation? Now, look at this one. Here we have the beaker. This one is the beaker. We have beaker. In the beaker, we have water up to this level, right? We also have peeled potato, right? We also have a cavity in the peeled potato. Now we have saturated sugar solution before the start of the experiment. After the experiment, you have the sugar solution formed. Now, what has happened and how has water moved from the beaker up to the cavity that was containing the saturated sugar solution? That is what I want us to dive and navigate through today. Now, class, what we know is that the process of osmosis basically involves movement of water molecules from a region of high water concentration to a region of low water concentration. And therefore, as such, class, we can see that the water in the beaker has high water concentration as compared to the cavity containing the saturated sugar. Very good. That is point number 1. Now, from there, you can see that we have a hypotonic solution in the beaker. We also have a hypertonic solution in the peeled potato cavity. Now, what can you next tell us? And we know that water moves from a hypotonic solution to a hypertonic solution. Very good. That is clear again. Now, the problem is this water has to move along these cells up to the cavity. So you have to tell us how has water moved from the beaker up to the time it has reached the cavity. That is where you need to put more emphasis and clarity on how has water moved from the beaker up to when it reached the cavity. Now, class, we say water in the beaker is hypotonic to the adjacent cells of the potato. For example, this is the water, right? These are the adjacent cells of the peeled potato to the water in the beaker. And therefore, through the process of osmosis, water will move from the beaker to the adjacent cells of the peeled potato. Now, from there, the adjacent cells will accumulate more water up to the time it also becomes dilute as compared to the next adjacent cells, right? Now, therefore, water will move from the adjacent cell that has accumulated water and has now become hypotonic to the nearby cells. Now that process keeps on repeating until the water reaches the cavity, hence forming the sugar solution. Now, the point that needs more clarity, more emphasis, more explanation is this water here is going to move to the cell sap of the adjacent cells. Once it enters the cell sap of the adjacent cells, the cell sap of the adjacent cells gets diluted. And once the cells of the adjacent cells gets diluted, it becomes hypotonic to the cells next to it, and therefore that brings about water to be absorbed from the adjacent cell that becomes dilute to the next adjacent cells until it reaches the cavity of the peeled potato. And the process is repeated until water reaches the cavity, forming the solution. And at times you ask the observation. Observation number 1 is the level of water in the beaker reduces. Very good. Now, the sugar solution in the cavity increases. Those are the two observations and the explanation we have already done. Now, let's come to another problem. In an investigation, a student extracted 3 pairs of purple cylinders. Using a cork pourer, the cylinder was cut back into 50 milliliters. Now, he put that one in a beaker containing a certain solution. Now, the results are these, the feature. Feature of length, how has length behaved? It was 50, right? It has moved to 56, very good. The stiffness, it became stiff. Stiffness basically means it became hard, firm, and rigid. Now, basically, that means it must have been placed in a hypotonic solution. Because we can see that the length basically increases when it has absorbed the water, it has expanded. And now once it expands, it becomes firm and rigid. And once it becomes firm and rigid, the stiffness of the potato cylinder also increases as well the length. Now, how can we account? Observation number 1 is the length has increased, very good, and also the potato cylinders become very stiff. Those are 2 observations. Now, let's explain the observations. Now we say the purple cylinder was placed in a hypotonic solution. Through the process of osmosis, water molecules moved from the purple cylinder, from the solution in the beaker into the purple cylinder. Now, once water gets into the purple cylinder expanded. And we know that the exact and outer pressure, target pressure, which will be equalized by the wall pressure, now attaining the stiffness and hence increase in length as well. That is done. Let's come to what will be a suitable control for the above setup of investigation. Now class, a control setup is you use a boiled potato. A boiled purple cylinder. Why? Because once you boil, the cells will be denatured, and therefore, once the cells are denatured, the process of osmosis is thus hindered, and therefore, a control experiment for this is using a boiled purple cylinder. Wish you all the best. Stay tuned for the successive incoming tutorials. Wish you all the best. Be blessed and stay safe.